Assalamu alaikum warahmatullahi wabarakatuh.
If I ask you to imagine a Porsche right now, just picture one in your head, you are almost certainly picturing a screaming gas engine.
Oh, absolutely.
Right, like an aggressive guttural roar just screaming down a straightaway. The entire brand feels fundamentally welded to the internal combustion engine.
It really does. It's their whole identity.
Yeah, but, well, here's the crazy thing. The very first car Ferdinand Porsche ever built didn't have an exhaust pipe.
Not a single one.
It didn't make a sound at all because back in 1898, Ferdinand Porsche actually built an electric car.
Which is just, it remains one of the greatest historical ironies of modern engineering.
Totally.
Because to understand Porsche today, the racing dominance, the luxury, the massive technological leaps, you really have to look at a history that is forged entirely out of contradictions.
Right, and that's exactly what we're getting into today. Welcome to today's deep dive, everyone.
We have a lot to cover.
We really do. We're pulling from this massive stack of historical archives, corporate newsrooms, design analyses, and automotive records to figure out how this company actually built its DNA.
And our mission for you, listening right now, is to uncover how a company that is just so synonymous with elite sports cars survived by, well, doing some incredibly unexpected things.
Like building tractors.
Exactly. Building tractors, fighting these bitter historical grudges, and completely reinventing itself literally whenever the walls started closing in.
Okay, let's unpack this because we have to start with that electric shock you mentioned. Looking at the sources, Ferdinand Porsche himself had absolutely no formal engineering degree.
None at all. And what's fascinating here is that he essentially bootlegged his own education.
Wait, what do you mean bootlegged?
Well, as a young man, he was working at this electrical company in Vienna. Right? And he would literally sneak into university classes after his shifts.
You're kidding. Just sneaking into lectures.
Just sneaking in, yeah. He just wanted to absorb the theoretical physics behind the circuitry that he was wiring during his day job. So his earliest obsession wasn't combustion at all.
It was electricity.
Exactly. It was electricity.
And that obsession turns into a physical vehicle incredibly fast because by 1899, he unveils this thing called the Loaner Porsche Semper Vivus.
Which translates to always alive, by the way.
Always alive, right. And our sources highlight that this isn't just an electric vehicle. It is actually the world's first functional hybrid.
Yeah, the very first.
Which is wild for 1899. He puts these electric motors directly into the wheel hubs and then uses a gas engine as like an onboard generator to keep them powered.
And he also throws in the first four-wheel brakes on a production car, just for good measure.
Just casually inventing modern braking. But I want to focus on those wheel hub motors because putting the motor inside the wheel seems like a massive leap for the 19th century.
Oh, it's a masterclass in efficiency. Because think about a traditional car drivetrain.
Okay.
You have an engine, right? And that turns a transmission.
Right. Which turns a drive shaft, which turns a differential, turning an axle, and then finally that turns the wheel.
That's a lot of moving parts.
Exactly. Every single time those metal components interact, you lose power. It gets lost to friction and heat. It's basically like pedaling a bicycle chain that has to turn 5 different gears before it actually turns the tire.
Okay, yeah, that makes sense. You're just bleeding energy the whole way.
Exactly. So Porsche just bypassed all of that. He put the power generation directly at the point of contact with the road.
See, I am struggling to understand why that didn't just immediately take over the world.
Well,
Like, if Porsche had a functional hybrid vehicle figured out before the 20th century even started, why did the auto industry spend the next 100 years perfecting the gas-powered transmission instead?
because you hit a chemical wall.
A chemical wall.
Yeah. The physics of the hub motor were flawless, but the chemistry of 19th century batteries was just an absolute nightmare.
Oh, right. They didn't have lithium-ion back then. Not even close. We are talking about old-school lead-acid batteries.
Oh, heavy.
Unbelievably heavy. To get any meaningful voltage out of them, Porsche had to load nearly 2 tons of lead into the vehicle.
2 tons? Just in batteries?
Just the batteries. So on perfectly flat pavement, cruising around Vienna, it glided beautifully.
But I'm guessing hills were a problem.
A massive problem. The moment it faced an incline, That monumental weight just completely overwhelmed the motors. The energy density simply wasn't there to support his mechanical vision.
Wow. So hitting a chemical wall means he has to find a mechanical detour.
Exactly.
And that detour leads him straight to internal combustion. Because we jump forward to 1922, and Ferdinand is working for Austro-Daimler.
Yeah.
And he designs this radically different car called the Sascha, named after the financier, Count Sascha Collerat.
A very wealthy backer.
Yeah. And we go from a 2-ton lead behemoth to a vehicle that weighs only 598 kilograms.
It's tiny.
Less than 600 kilos, with this tiny 1.1-liter, 50-horsepower engine.
Which is completely intentional. The Sascha really establishes the core engineering philosophy that still defines Porsche today.
Doing more with less.
Exactly. The belief that a lightweight, highly efficient system will always outperform some massive brute force machine.
And they proved it right, because they took 4 of these little cars to the Targa Florio in Sicily.
Oh man, the Targa Florio.
The Targa Florio is legendary. It is this punishing race on public mountain roads.
Yeah, just brutal terrain.
And our records show they actually painted the cars red to blend in.
Wait, to blend in with what?
With the Italian cars, so they wouldn't get stolen in Italy.
Oh wow, that's practical.
Right. And they marked the hoods with playing card suits like hearts, diamonds, clubs, so the pit crews could tell them apart through all the dust.
That's amazing.
But, I mean, running a 50-horsepower engine against cars with power plants 4 or 5 times larger, that seems like a suicide mission on a mountain track.
Well, if we connect this to the bigger picture, the Targa Florio was 432 kilometers of just brutal roads.
Yeah.
And it had 6,000 turns.
6,000.
6,000. So in an environment that requires constant braking and cornering, a massive heavy engine suddenly becomes a liability.
Oh, because of the momentum.
Right. The inertia literally pulls you off the road. But the Sascha, with its extreme weight reduction and really nimble chassis, it didn't have to slow down nearly as much for the corners.
It just carried its speed through the turns.
Exactly. In fact, one of the Saschas finished the race with an average speed only 8 kilometers per hour, slower than the overall winner.
And the winner was a massive Mercedes, right?
Yep, giant Mercedes.
So that philosophy of minimalist efficiency just absolutely humiliated the heavyweights of the era.
It really did.
But this brings up a huge contradiction. How does a designer who is just obsessed with 598-kilogram racing cars end up designing the heaviest, most bloated military tanks in human history?
Yeah, it's a dark pivot.
Because that ideological compromise happens when the state takes over the checkbook in the 1930s.
It does. And actually, before we delve into this specific era, it is critical to state clearly to you listening that we are simply reporting the documented historical facts from our sources here.
Absolutely.
We are not endorsing any of the ideologies of the Third Reich, but the historical record shows that Ferdinand Porsche transitioned from an independent engineer to a deeply embedded state-sponsored contractor.
Right. Our sources note he became a member of the Nazi Party and the SS, eventually reaching the rank of SS Oberfuhrer.
Yeah, and it starts with a civilian commission.
Right. Adolf Hitler tasks Porsche with designing the people's car, which we know as the Volkswagen Beetle.
Get a crazy detail from the sources. The very first prototypes of the Beetle were actually built and tested right inside Porsche's private garage in Stuttgart.
Just in his house's garage. That's wild.
Yeah.
But as the war breaks out, the civilian project evaporates and the factory pivots entirely to military production.
Everything shifts to the war effort.
They design the Kübelwagen and the Schwimmwagen, which actually becomes the most produced amphibious car in history.
Over 15,000 of them built.
But the production of these vehicles relied on a really grim wartime reality.
Yeah, the factories utilized approximately 300 forced laborers.
Right, primarily Soviet and Polish prisoners of war.
Just to meet the crushing manufacturing demands of the state.
And those demands escalated fast. They went from light transport vehicles to heavy armor. And this is where I struggle to reconcile his engineering philosophy.
The tanks.
The tanks. Porsche is contracted to build the Elephant tank destroyer and eventually the Panzer VIII Maues.
The Maues is just unbelievable.
The Maues was the heaviest fully enclosed armored fighting vehicle ever built. It weighed 188 tons.
It's the complete antithesis of the Sascha.
Exactly. Why would an engineer famous for lightweight efficiency suddenly build a rolling steel fortress?
Well, it comes down to the mechanics of moving that much weight. Traditional mechanical gearboxes simply shatter when trying to move 188 tons of steel.
Gears just break.
Yeah, the torque requirements literally tear the metal apart.
Yeah.
So Porsche reverted back to his 1899 obsession. Yes. He designed incredibly complicated gasoline-electric hybrid drive systems for these tanks.
Wait, he put a hybrid engine in a tank?
He did. A massive gas engine spun a generator, which then fed power to electric motors that drove the tracks.
So he basically tried to put the Semper Viva system inside a 188-ton tank.
That is exactly what he did. But as you can imagine, the combat environment of World War II is very different from a paved street in Vienna.
I would assume so, yeah.
These hybrid systems required massive amounts of copper, which was severely rationed during the war.
Oh, right.
And they were incredibly prone to overheating and breaking down.
Which is bad news in a war zone.
Terrible news, because when a 188-ton tank breaks down into the thick mud of the Eastern Front, you cannot tow it.
It just becomes a building.
Exactly, it becomes a static bunker. So his insistence on these highly complex experimental drive systems actually earned him a reputation among the German high command as a, quote-unquote, mad scientist.
Wow.
Yeah, someone whose designs were technically brilliant on paper, but operationally disastrous in the mud.
And, I mean, you don't build weapons of war without making enemies. And you definitely don't take over foreign factories without triggering severe blowback.
No, you do not.
The fallout from this era nearly destroyed the Porsche family name completely, and it leads directly into the post-war rebirth of the company.
Because following the war, Ferdinand Porsche was arrested by French authorities for his wartime activities.
Right, so the survival of the company falls entirely to his son, Ferry Porsche.
Yes. And with his father imprisoned, Ferry relocated whatever assets he could salvage to an old sawmill in Gomund, Austria.
A sawmill. We are talking about a luxury brand literally hammering aluminum over wooden bucks in a shed in the woods.
That's an incredible image.
It really is. And Ferry manages to hand-build the first 49 aluminum-bodied Porsche 356s right there in that sawmill.
And this is also when the famous crest is born, right?
Yeah, the rearing horse of Stuttgart, layered with the antlers of the state of Württemberg. Our sources are a bit split. Some say Ferry sketched it in New York, while others credit an engineer named Xaver Rimspeis.
Either way, it becomes iconic.
Very. And the 356 saves them. It sets up the defining moment of the company in 1963 when the successor to the 356 is finally unveiled.
And they call it the 901.
Right. Which triggers an immediate and aggressive legal threat from Peugeot.
Peugeot claimed they held the trademark for any three-digit car name with a 0 in the middle.
Now, I have to admit, I've heard this trivia a million times.
The 0 in the middle thing.
Yeah. But I've always been so confused by it. Why would Peugeot care so much about a 0 in the middle of a number? It seems like an incredibly petty thing to take to international court.
On the surface, yeah.
Because of this claim, Porsche just swaps the 0, which they already manufactured, by the way, for a 1, and the legendary 911 is born.
The 911.
But the 0 dispute makes no logical sense to me.
Well, it makes perfect sense when you realize it had absolutely nothing to do with numbers.
Really?
Not at all. During the occupation of France in World War II, Ferdinand Porsche and his son-in-law, Anton Pieck, essentially took administrative control of Peugeot's factories in Sochaux.
Oh.
Yeah. They forced the French workers to build parts for the German war effort.
Okay, here's where it gets really interesting.
The Peugeot family and their workers didn't just resent this, they actively fought back.
The workers did?
Yes. French line workers purposefully sabotaged the German parts they were building.
That is incredibly brave.
It was. They slowed down production schedules, they miscalibrated machines, and they even started localized fires in the factory.
Just constant resistance.
Exactly. And because the plant was producing German munitions, it was subjected to deadly Allied bombing raids.
Oh, man.
And then, when the German forces finally retreated from France, they looted the Peugeot plant. They physically unbolted and stole over 1,500 Peugeot machine tools, shipping them all back to Germany.
Wow. So decades later, when Peugeot issues a trademark injunction over the name 901, that is not corporate housekeeping.
No.
That is a targeted historical grudge.
A massive grudge.
They are using a copyright claim to serve a dish of cold revenge directly to the family that stole their factory.
Exactly. Peugeot couldn't retrieve their stolen machine tools, but they could absolutely force the Porsche family to strip the badges off their brand new flagship car.
Just to prove a point.
Just to make them bleed a little bit.
That is fascinating. And, that willingness to endure the mud, whether literally in a Jimin sawmill or figuratively in a courtroom against Peugeot, it forged a company that would do anything to survive.
Oh, absolutely anything.
And if you dig into their hidden engineering archives from the 50s to the 90s, you realize they applied that systems-level survival thinking to completely bizarre industries.
Yeah, their agricultural division is a stunning example of this.
Tractors.
Porsche built over 125,000 tractors.
I had no idea the number was that high.
Yeah, and they didn't just slap a badge on a generic plow either. They tackled very specific agricultural challenges.
The P312 coffee train is the perfect example from the sources.
Oh, the coffee tractor.
Yes. They engineered this specific tractor for Brazilian coffee plantations, and it was shaped smoothly, almost like a submarine.
A submarine.
Yeah, so the chassis wouldn't snag and destroy the fragile coffee plants as it drove down the rows.
That's brilliant.
And they also completely redesigned the engine to run on petrol instead of standard diesel.
Why petrol?
Because farmers found that the thick diesel exhaust fumes were seeping into the coffee beans and ruining the flavor.
Wow. So they changed the fuel just to protect the taste of the coffee.
Exactly. And that same ergonomic, user-first problem-solving translated to aviation, too.
Right. Porsche was actually hired to help design the cockpit layout for the Airbus A300 commercial airliner.
Which is wild. How does building a sports car translate to flying a massive commercial jet?
Well, it comes down to cognitive load.
Cognitive load, okay.
Yeah. In a race car, a driver has milliseconds to read a gauge and make a life-or-death decision, right?
Right, going 200 miles an hour.
Exactly. You cannot have a cluttered dashboard. So Porsche applied this exact same philosophy to the A300. Instead of grouping air crash instruments by their mechanical functions, which was the standard at the time, Porsche grouped them based on the pilot's visual scanning patterns.
Oh, so putting the most important things right where the eye naturally goes.
Exactly. They reduced the cognitive friction in the cockpit, basically applying a motorsport mindset to commercial aviation safety.
They were just taking contracts everywhere. I mean, they built the V-twin engine for the Harley-Davidson V-Rod. They engineered the underwater electronics for Seabob watercrafts.
That's a weird one.
Very weird. They even built an electronically adjustable luge sled for the Olympic medalist Jord Hackl.
They really did everything.
But honestly, none of those compare to the sheer weirdness of the C-88 concept.
Oh, the China project.
Yes. In 1994, the Chinese government asked foreign automakers to pitch a cheap, reliable people's car for their massive emerging market.
But Porsche designed an entirely new vehicle in just 4 months.
4 months.
4 months. And it was just a stripped-down Econobox.
It had manual windows, cheap plastic interiors, and a single built-in child seat.
Right.
But the craziest detail is that Porsche completely scrubbed their own identity from it.
Yeah, they hid themselves.
There was no Porsche crest anywhere on the car. They designed a brand new logo featuring 3 interconnected circles to represent China's one-child policy.
Which is a very specific design choice.
Very specific. China ultimately rejected the design, but I am baffled by the strategy. Why would an elite luxury brand risk its prestige by building a cheap, anonymous plastic sedan?
It's a great question. And it really raises an important point about corporate vanity versus corporate reality.
Okay.
Because in the early 1990s, Porsche was staring over a financial cliff.
They were in trouble.
Deep trouble. Sales in the United States had completely collapsed. The company was hemorrhaging money.
Oh, wow. I didn't realize it was that bad.
Oh, yeah. The C-88 wasn't an exercise in brand expansion. It was a desperate bid for cash flow.
Just trying to survive.
Exactly. If tapping into the high-volume Chinese market meant designing a cheap sedan completely anonymously, they would do it to keep the lights on in Stuttgart. Survival always trumps prestige.
And that instinct for ruthless adaptation is exactly what's playing out right now.
How so?
Well, Porsche is facing another existential cliff. The death of the internal combustion engine.
Right. The EV transition.
Exactly. How does a company whose entire emotional appeal is tied to the sound of an engine survive the transition to completely silent electric vehicles?
Well, they treat mechanical engineering like a software update.
A software update.
Yeah. They're entirely unsentimental about the technology if changing it ensures their survival.
Okay, that makes sense.
We saw this back in the 96 generation of the 911, right?
Right.
When they replaced the sacred air-cooled engine with a water-cooled system just to meet emissions standards.
Oh man, the purists hated that.
Purists absolutely revolted, but it saved the car. And now they are applying that exact same unsentimental engineering to electromobility with the Taycan.
And they didn't just build a standard EV either. They completely re-engineered the underlying architecture.
It really pushed it.
Most of the electric vehicle industry operates on a 400-volt system, but Porsche built the Taycan on an 800-volt system.
Which is huge.
See, I know that sounds like a meaningless marketing number to a lot of people, but the sources emphasize it's actually a massive physics advantage.
Oh, it is. It's basic Ohm's law.
Break that down for us.
Sure. Electrical power is voltage multiplied by current.
Okay.
If you double the voltage to 800, you can achieve the exact same power output while having the electrical current.
So twice the volt, half the amps.
Exactly. And why does that matter? Because current creates heat. And heat is the ultimate enemy of an electric vehicle. If you take a standard EV to a racetrack and do 3 really hard laps, the battery will overheat.
And then it just slows down.
Yeah, the car's computer will aggressively throttle your power to prevent the battery from literally melting.
So by doubling the voltage, Porsche drastically reduces the thermal load. The car can repeatedly launch and maintain track speeds without engaging that thermal throttling.
Exactly. It's essentially using electrical theory to solve a mechanical cooling problem.
Yeah, it is so smart.
And it also allows them to use significantly thinner copper cables throughout the entire vehicle, which sheds weight and improves charge times.
Wow. It is the Sasha philosophy applied to a lithium-ion battery.
It really is.
Doing more with less. But Porsche isn't abandoning combustion entirely.
No, they're not going quietly.
Not at all. They are spending millions to engineer their way out of the climate problem through synthetic eFuels.
The Chile project.
Yeah. They've partnered to build the Haru Oni pilot plant all the way down in Punta Arenas, Chile.
And the chemistry happening at Haru Oni is just staggering.
Tell me about it.
They're using these massive wind turbines to generate electricity.
Okay.
That electricity powers an electrolyzer, which splits plain water into oxygen and green hydrogen.
It's just using water and wind.
Right. Then they take that green hydrogen, they combine it with carbon dioxide that they've literally pulled right out of the atmosphere.
Wait, they capture the carbon from the air?
Directly from the air.
Yeah.
And they synthesize it into methanol.
Okay.
That methanol is then refined into a liquid gasoline that is chemically identical to what you put in your car today.
So when you burn it in, say, a vintage 911, it still releases carbon out the tailpipe.
Yes.
But it's completely carbon neutral because you're just releasing the exact same carbon you capture from the air to make the fuel in the first place.
Exactly. It's a closed loop.
That is mind-blowing. But why build this in Chile? Why not Germany?
It is entirely dictated by the wind.
The wind?
Yeah. In Punta Arenas, the wind blows hard enough to run those turbines at full load for about 270 days a year.
Oh, wow.
A similar wind turbine in Germany might only run at full capacity for 66 days.
That's a huge difference.
It is. And you need massive, uninterrupted, cheap green energy to make the electrolysis financially viable.
So what does this all mean? I have to challenge the motive here a little bit.
Sure.
Is this eFuel project truly a scalable future for global mobility, or is it just a massively expensive, incredibly elaborate life support system so a few wealthy purists can keep revving their vintage 911s?
It's a fair question. Honestly, it's dual purpose.
Okay.
Yes, it is undeniably a heritage project. Porsche wants the millions of combustion engines they've built over the last 70 years to remain on the road long after fossil fuel extraction is banned.
Right, protect the legacy.
But it is also a deeply pragmatic global energy solution.
Have so.
Well, you cannot build a power line from Patagonia to Europe to transmit that incredible wind energy.
No, obviously not.
But by converting that kinetic wind energy into a liquid chemical fuel, you can pump it onto a standard cargo ship and integrate it directly into the world's existing fueling infrastructure.
Oh, so it's basically liquid wind energy.
Exactly. It's a bridge technology for aviation, shipping, and heavy industry, not just sports cars.
It is wild to look at the full scope of this. I mean, whether you are listening to this right now trying to navigate a pivot in your own career or trying to innovate in a really rigid industry, this story is just a masterclass.
It really is.
It's about how to adapt radically without losing your core identity. I mean, from sneaking into university classes, surviving the mud of the Eastern Front, building submarine tractors, fighting off Peugeot's revenge, and now capturing Patagonian wind to save the combustion engine.
And, if you want a final thought to really demonstrate how cyclical innovation is, consider this.
Hit me.
We talked about Ferdinand Porsche's very first innovation back in 1898, the electric wheel hub motor on the Sempervivus.
Right.
It was discarded, He was written off as a failure because the lead-acid battery chemistry of the 19th century just couldn't support it.
Right, the 2-ton battery that couldn't climb a hill.
Exactly. But the mechanical principle of bypassing the drive shaft to eliminate friction, that was absolutely flawless.
It was just ahead of its time.
So ahead of its time that 70 years later, when NASA engineers were tasked with building a vehicle to drive on the moon.
Wait, really?
Yes, an environment where extreme efficiency and weight reduction are literal matters of life and death.
Right.
They dug through the historical archives, and the lunar roving vehicle used by the Apollo astronauts was built using the exact same electric wheel hub motor principle that Ferdinand Porsche pioneered in 1898.
That is absolutely mind-bending. A discarded 19th century patent ending up on the surface of the moon.
It forces you to ask, what discarded ideas, what abandoned prototypes are sitting in our junkyards right now, just waiting for the surrounding technology of our era to finally catch up and make them viable?
What a brilliant question to end on. It proves that sometimes the only difference between a failure and a revolution is 100 years of patience. The next time you hear that aggressive roar of a gas-powered 911 out on the street, just remember, the whole thing started with a silent electric hum. Thank you so much for joining us on this deep dive. Keep exploring the unexpected histories behind the everyday things around you. Catch you next time.
All right, all right.